Good evening, class. My name is TT, and today I've got a presentation for you. Right, we're talking about the groundwater monitoring. Right, so the observation gap between today is going to be how I'll be discussing how there's a lack of continuous long-term monitoring in terms of how our groundwater systems are working. Right, we aren't able to understand how important it is that we have moving water around the earth. These water systems that we have built in, right? All these things that obviously affect and change human activities as we grow on, right? So groundwater is one of the most important freshwater resources on earth, right? Supplying millions of water for people, supports agriculture, obviously helps maintain the oceans, the rivers, the lakes, the ponds, obviously all the water ecosystems around the world, right? However, there is obviously a lack of care in terms of collecting data in these water regions, right? However, obviously there is some parts that collect good enough data for us to obviously have an idea and try and maintain some water systems in the groundwater system department. However, we don't see as many people doing long-term monitoring. We don't have people obviously going out and obviously getting all this data from a long period of times. Obviously, reason being because of these gaps that we have now in the data that we collect. So in some regions we're collecting X, Y, and Z data, right, in terms of the groundwater, but in some regions we don't, right? The scientists obviously have some data missing some, meaning that the inaccurate data supply means that they can't make accurate information systems, they can't make accurate answers. We can't predict when we have droughts, we can't predict rain properly, we can't predict the moisture of the soil, and then obviously this affects our ecosystems, right? Moving on now is the lack of consistent observation weakens our ability to have informed decisions, like I said, right? For example, farmers depend on groundwater to be able to produce all this food that we need to sustain humans, right? It also affects when they can time the irrigation periods, for example, during dry periods, right? If groundwater levels are declining, we don't have reliable data to obviously give these answers, right? Communities won't be able to realize there's a problem until a water shortage happens, and in these cases, right, it's severe. It leads to scientists complaining because obviously they need longer time to be able to, and more data to predict better things for us. Moving on to chapter 5, we obviously discussed the importance of integrated observation systems, right? The author obviously explaining that understanding Earth is a connected system. It requires observation, collected consistently, and sharing organizations across the world. Groundwater monitoring is an example of an area of better integration and data that is needed because information is scattered around the world among different agencies as well, using different methods to collect this data. I think a realistic way to address this observation gap would be expand monitoring around groundwater business, having automated systems and sensors to track these things for us, especially with the use of AI nowadays. I think we can be able to develop things where you don't need people to monitor this. We can have systems there that can track the water levels and all sorts, right? Because obviously if we begin to monitor the groundwater levels more continuously, the data will be transmitted will be immense for the scientists to give us better decisions and better and accurate answers. This effort obviously could include organizations such as the United States Geological Survey, right, state water agencies, universities as well, local water management partnerships as well, working together to increase monitoring coverage and reducing costs. I think that the data sharing plan is also very important. All collected data should be standardized in format, make it public available through a shared platform. This would allow scientists to combine and groundwater information together with rainfall, steam flow, and soil moisture data as well to gain a more complete understanding of the Earth ecosystem. A realistic timeline could begin with identifying and monitoring the gaps that we have and selecting pilot locations where we're going to put these things within a 6-month period. Within a year, sensors will be installed in primary areas connected to shared data. And then within 2 years, the network potentially could move on to a more expanded and integrated with all and environmental observation systems, right? However, obviously, all this stuff here, there's obviously going to be disadvantages, right? So one limitation might be the proposal cost, right? Installing all this equipment, maintaining and monitoring stations requires funding and technical expertise. A practical solution would be to begin with a smaller pilot projects used among partnerships, federal agents, universities, local governments will be able to share resources and responsibilities. Coming towards the end of it now, in conclusion, success would mean reliable long-term groundwater observations that are easily accessible, integrate with other Earth system data, creating better monitoring would improve, obviously, drought prediction, water management, and our understanding of the environment change. However, I'll end it with one question. How can scientists and the government work together to ensure that the groundwater data remains standardized, accessible, and useful for future generations? So that'll be the challenge for them now. Thank you so much for listening. Have a good evening.